Is my
Yes, we
sound?
can hear you. We can
Oh,
hear you now.
okay.
Good, good.
Maybe I will start another one. Maybe where I stop. So yeah, trigonometry. So katoa. So katoa. So stand for the sine, cosines, and tangents. And maybe I will give another example as my connection just stopped. Maybe this one's 13, 12, and 5. So if we're trying to find the sine, cosine, tangents, cotangents, seconds, and coseconds, we need to use this tree, so katoa. So if we're looking for the sines of theta, it is opposites over the, sorry, this is h, opposite over the hypotenuse. So the opposite of the theta is the 12, and the hypotenuse is 13. As for the cosines of theta, it is adjacent over hypotenuse, which is 5 over 13. And as for the tangents of theta, it is opposite over adjacent, which is the opposite of theta is 12. And the adjacent is 5. Now we're looking for the cosecant of theta, which is 1 over sine theta. So we're just gonna flip the signs over. So instead of 12 over 13, we are writing it as 13 over 12. As for the secants of theta, it is 1 over cosecant of theta. So we just flip the cos. It's gonna be 13 over 5. And as for the cotangents of theta, it's gonna be 1 over tan theta, tangent theta. So it's gonna be 5 over 12. So that's basically all you need to know for the basic of trigonometry. Another one you need to remember is that there is special angle on trigonometry. And a lot of school actually need you to remember this special angle. Not all of them, but just a few of them. They usually don't give you this when they're in exam or you need to remember them. And it's quite easy. So we got 0 degree, then 30 degree, and 45 degree, 60 degree, and 90 degree. You just need to remember 5 of this. So for the signs, you actually just need to remember the sign and you can find the other ones. So for the sign, it is 0 degree, sine 0 degree is 1, sine 30 degree is half, sine 45 degree is square root 2 over 2, sine 60 degree is square root 3 over 2, and this one, sine 0 degree is 0, sorry. So as for sine 90 degree is 1. As for the cosines, if you remember the sine, you're gonna remember the cosines, okay? So cosine is basically sine, but flip over. So as cosine 0 degree, it is 1. Cosine 30 degree is the second one. We read it from here to there as for the cosines. So cosine 30 degree is square root 3 over 2. Cosine 45 degree is square root 2 over 2. Cosine 60 degree is half. And cosine 90 degree is 0. Then we are going to find the tangents. Here, tangents is basically sines over cosines. So we're going to find tangent for 0 degree, which is sine for 0 degree over the cosine of 0 degree, which is 0 over 1. You can look at this one, which results in 0. So tangent 0 degree is 0. Then we're gonna look for tangent 30 degree. So sines 30 degree over cosines 30 degree, which is half over square root 3 over 2. We can also write this as half divided by square root 3 over 2. If you find something like this, you can just flip it over, okay? So half, you can change the divisions into multiplications, but we need to flip the ones after it. So it's gonna be 2 over square root 3. This one gonna be, we can just delete this, and we're gonna be 1 over square root 3. We cannot keep it like this. We need to move the square root 3 into the upper sides. So it's going to be 1 over square root 3. To move it to the up, we need to multiply it by square root 3. So it's going to be square root 3 over. So if there's like square roots multiplied by square roots with the same number in the square root, we just need to delete the square roots. So it's going to be 3. So tangent 30 degree is square root 3 over by 3. I'm going to delete this one first. Now continue. So tangents 40, which is sine 45 degree over by cosines 45 degree. This results in square root 2 over 2 divided by square root 2 over 2. We can change this to multiplications by flipping the ones after it. This is gonna be 2 square root 2 over 2 square root 2, which results in 1. So tangent 45 degree is 1. Then we continue to tangent 60 degree. which is sine 60 degree, over by cosine 60 degree, which is square root 3 over 2, divided by half. We can change this to multiplications. So square root 3 over 2 multiplied by 2 over 1. This is going to be 2 square root 3 over 2. We can just 2 over 2 multiplied by square root 3. This is 1 square root 3, or we can just write it as square root 3. For the last one at tangents, it is tangents 90 degree, which is sine 90 degree over cosine 90 degree, which is 1 over 0, and this is what do you call it? Wait. Countless. Yeah, countless. 1 over 0 is countless. Now, after we find the sine, cosine, and tangent, we also going to find this 5 special angle for cosecants, secants, and cotangents. For cosecants, it is 1 over sine. So we're gonna find the cosecants of 0 degree, which is 1 over sine 0 degree, which is 1 over the sine of 0 degree. This one, 1 over 0 is also uncountable. So this we write here, cosecants of 0 degree is uncountable. Then we find the cosecants of 30 degree is 1 over sine 30 degree, which is 1 over sine 30 degree. Right here is half. So 1 over half, we can write it as 1 over 1 divided by 1 over 2. We change this to multiplications. 1 over 1 multiplied by 2 over 1. So this is going to be 2 over 1 or 2. So cosecant of 30 degree is 2. Continue to 45 degree. It's going to be 1 over sine of 45 degree. 1 over sine 45 is square root 2 over 2. An easy way, you can just move it up and flip it over. So it's going to be 1 multiplied by 2. Flip this 2 over. 2 over square root 2. This one's 2 over square root 2. We need to multiply it by square root 2. So it became, we can just write it here. 2 square root 2 over, if there is square root with the same number, we can just delete the square roots. So 2 square root 2 over 2, which is 2 over 2, multiplied by square root 2. 1 multiplied by square root 2 is square root 2. So the cosecant of 45 degrees is square root 2. Continue to the 60 degree. Cosecant of 60 degree is 1 over sine 60 degree, which is 1 over sine 60 degree is square root 3 over 2. We're gonna flip this over, so it's gonna be 1 multiplied by 2 over square root 3. So 2 over square root 3. We're gonna multiply it by square root 3. It's gonna be 2 square root 3 over 3. So the cosecant of 60 degree is 2 over 3 square root 3. And the last one, cosecant of 90 degree, which is 1 over sine 90 degree, which is 1 over 1 and this one. We are also done with the cosecants. And we move to the secants. Secant is 1 over cosines. So we're going to find the secant of 0 degree. 1 over cosine 0 degree, which is 1 over 1. The secant of 0 degree is 1. Actually, you don't really have to count this one. The same as the sines and cosines, we just need to flip it over. So if we find the cosecants already, we just need to flip it over to find the secants. So for secant, this is 1. Then the next one should be 2 over 3 square root 3. Then the next one should be square root 2. So secant 60 degrees should be 2. And secant 90 degrees should be uncountable. Same with the cotangents. We just need to flip over the tangents. So if we've already find the tangent, this one, we just need to flip it over from the uncountable one to 0. That is cotangents. So this cotangent 0 degree should be uncountable. Cotangents 30 degrees should be square root 3. Cotangents 45 degrees should be 1. Cotangent 60 degrees should be square root 3 over 3. And cotangent 90 degrees should be 0. Maybe you can screenshot this just to remember, or you can just find it on Google if you need it sometimes in the future. Just gonna write it. This one, you need to remember this one. You just need to remember this one. As for the cosecant, it is cosines. It is sines, but flip over. As for the tangents, it is sines over cosines. As for the cosecants, it is 1 over sine. Secants, it is 1 over cosines. And as for the cotangents, it is 1 over tangents. So this is an easy way to remember the perfect angle. You can screenshot it. Oh yeah, another thing to add for this one, trigonometry, there's also a special number to this size. So if you have a triangle with a right angle on one of the angle, they usually have this kind of number: 3, 4, 5, 6, 8, 10. No, this one. 5, 12, 13, 8, 15, 17, 7, 24, 25. You don't really have to remember this 4, but if you remember this 4, it's actually easier for you to solve this kind of problem. So what is this number? You see there, from this number, there's the biggest number of those 3. This biggest number is actually the hypotenuse. So if you got the hypotenuse of 5, then the other side is 4. Maybe you got the opposite of 4. And you're asked to find the adjacent. You don't need to find it because from this one, we know that the adjacent is 3. It's always going to be 3. Same thing goes for if we have a triangle. So we got the opposites of 5. We also got the adjacent of 12. And we are asked to find the hypotenuse, the C. We can know that the C is 13 because this is a special triangle. So from this tree, there's always one of the biggest number, right? The biggest number always gonna be the hypotenuse. As for these two numbers, it can be flipped over as opposites or as adjacents. It doesn't matter which one it is. It can be both of them. Just the biggest number have to be the hypotenuse. You just need to remember this form. There's actually a lot of them, but this 4 is the basic. So if we have like 3, 4, and 5, we're gonna multiply this maybe by 2, and we got the number of 6, 8, and 10. This is also a number of special triangle. So any whole number ratio that are multiplied of this 4 one number will also work as for the special triangle. Maybe if I have a triangle, as a triangle of maybe I would say 26. Then there is maybe 24 here. So what are this? the B. As we can see, the hypotenuse, or the biggest number, 26. The other one is 24. And we are searching for the B. Maybe we can divide it by 2. We got B, 12, and 13. As we can see from here, there's a special triangle with the 12 and 13. So this B should be 5. Multiplied by 2, which is 10. That's all for the special triangle. We're gonna get into the identity of trigonometry. So if we have this, as you know, a whole circle has 360 degrees. So we start from 0 degree. Then we go over here. We go over here. Right here, we got the first right angle, which is 90 degrees. Then we go over here. We got 2 right angle. So 90 plus 90. Here is 180 degrees. Then we go over again. So from 0 to 90 to 180 to one more right angle. So 90 multiplied by 3, this is 270 degrees. And the whole circle itself is 360 degrees. So what we're going to learn here is we'll explain this first. This is the first quadrant. So from this 0 to 90 degrees. So 0 to 90 degrees. This is the first quadrant. So 90 degree over 90 degrees to 180 degrees. This is the second quadrant. Over 180 degrees until 270 degrees. This is the third quadrant. And over 270 degrees to 360 degrees. This is the fourth quadrant. Way my teacher teach this one is add sugar to coffee. This one, you need to remember this one. So add sugar to coffee. So this is the first quadrant, the second one, the third one, and the fourth one. So what is this add sugar to coffee? So basically, the add sugar to coffee, A, S, T, and C, A stands for all, which means all of them, the sine, the cosine, the tangent, the cotangent, the cosecant, secant, is all positive if they are in the first quadrant. So if they are 0 to 90 degree, they're all positive. So this, I just want to write here, the sines, cosines, tangents, cosecants, secants, and cotangents. It's all gonna be positive in the first quadrant. So it's between 0 and 90 degrees. As for the second quadrant, S is stand for sines, which is sines and the ones related to sine, basically 1 over sine, which also means cosines. So in S, sines and the sine flip, which is cosines, is positive in the second quadrant, which is 9 over 90 degrees until 180 degrees. On the third quadrant, to coffee, 2, we got T, which stands for tangent, and the flip of tangent, which is cotangent. We got tangent and cotangent as positive in this third quadrant, which is 180 until 100 over 180 until 270 degrees. And on the fourth quadrant, we got C, stand for cosines, and secants, which is positive on 200 over 270 degrees until 360 degrees. So in this specific quadrant, okay, maybe if in the second quadrant, any other than sine and cosine is negative. In the third quadrant, any other than tangent and cotangent is negative. And in the fourth quadrant, any other than cosines and cosecants and secants is negative. So maybe if I say like, maybe I'll teach it first. Okay. For this one, before we explain it, maybe you should know this first. So if we are trying to find like a number that represents like maybe we got here like the special angle, right? So sine 30 degree is half. So what if they're like over 90 degree? Maybe let's just say we have let's just say we have sines of 120 degrees. We got this special angle, but it's all just came to 90 degrees. So what is the number that represent this sine's 120 degree? So way is, if you're gonna find the result, that there is this one, okay? It's either 90 degree minus a number that results in the number you're looking for, or 90 degree plus a number that result in the number that is in the questions or you're looking for, or 180 degree minus a number that result in the number you're looking for, 180 degree plus a number that result in the number you're looking for, and it's continue to 270 degree minus a number as a result 270 degree plus a number. And the result you're looking for, 360 plus and minus a number that result in the number you're looking for. A way to remember this is, you see this one. This one, the one with the horizontal lines. Okay, if we find a number, maybe here, this one, 180 degree plus minus a number that results in the number you're looking for. Please wait a moment. Okay, sorry about that. Let us continue. And this one in the vertical line, the 360 degree and 180 degree. If you're using these two numbers, so plus or minus a number to find result in a number in the questions, either the sine, cosine, or tangent will not change. So for example, this one, we are looking for sine 120 degree. We're gonna use either 180 or 360. We're gonna choose one with the closer one, 180, minus a number that results in 120. So this one gonna be minus. This will be minus 60. So the number we're looking for is 60 degree. As I said before, if it is on 180 degree or 360 degree, it will not change the sine, cosines, or tangents. So it will stay sine 60 degree, which is, if we see here, sine 60 degree is square root 3/2. So the result for sine 120 degree is the same as sine 60 degree, which is square root 3/2. But we need to look over it again right here. 120 degree. 120 degree is on the second quadrant. Okay. And in the second quadrant, we see that sine is positive. So which means this sine of 120 degrees stays as positive square root 3/2. It's a different matter if we're looking for using this, the vertical ones, 90 degree and 270 degree. If we use either this 90 degree or 270 degree, the sine, cosine, and tangent will change. So if we are using that, the sines gonna change to cosines. The cosines gonna change to sines. The tangents gonna change to cotangents. Same with the secants. It's gonna change to cosecants. The cosecants gonna change to secants. And the cotangent gonna change to tangent. So for example, we're gonna use this one. Still the same questions. Sine 120 degree. But we're gonna use the one in the vertical lines. We're gonna use 90. So 90 result in 120. So it's more than 90. So it's gonna be plus another angle that results in 120. So this angle is 120 minus 90, which is 30 degrees. So as I said before, because we are using 90 degree, this sign, we need to change it to cosines. So the result of sine 120 degrees is cosine of 30 degree, which if we look here, cosines of 30 degree is square root 3 over 2. So cosine 30 degree is square root 3 over 2. And for the positive and negative of this result, we see from the questions. We don't see from the cosine 30. We see from the question, this is sine 120 degree, which is in the second quadrant, which sine is positive. So the results stay positive. So either way, if we're using the one in the vertical lines or in the horizontal lines, the results stay the same. Maybe another example, we're gonna use a higher number. We got cosines of 225 degrees. You can see 225 degrees. It is around here. Around, I would say here. So it's either 180 plus something to get to here, or 270 minus something to get to this. So we're gonna try using 180 first, because 180 is lower than 225. We're gonna plus an angle. This angle gonna be 225 minus by 180, which results in 225 minus 180 is 45. As for the 180 degree in the horizontal line, so it stays the same. So it's still cosines of 45 degree, which we see here is cosine of 45 degree is square root 2 over 2. And then after that, we're gonna see this cosines on 225 degree. So we see here 225 degree around this, the third quadrant. So cosines on the third quadrant, we see there's no cosines on the third quadrant, so the cosines is minus. So the result for cosine 225 degree is minus square root 2 over 2. Then we're gonna search it with another ones with 270 degree. Minus something because it's bigger than 225 degree. So this minus angle is 225 minus 270, which results in minus 45 degree. So the angle is 45 degree because we are using the vertical lines. As we can see here, cosines. Cosine change to sines. So cosine 225 degree is the same as sine 45 degree, which we see from the special angle. Sine 45 degree, this one, square root 2 over 2. Which I said before, we see the positive or negative not based on this one, but based on the question. So cosine 225 degree on the third quadrant, which cosine is not positive. So the result stay the same, minus square root 2 over 2. It seems our time is up. I guess I will end the class here. Maybe if you want to take a screenshots for the future. Or maybe I'll take it to send it to you guys later.
Well, thank you so much. This is fantastic. Fantastic. Okay. So you guys already learned a lot. Okay. So thank you, Nonfi. All right. This is fantastic because they are still like, you know, 4, 5, or 6 grade children. Okay. They already learned this. Okay. So we have to thanks Kak Nonfi that spent all this time, okay, to help you guys. Okay, we are hoping that Kak Nonfi also, okay, and her family can change their mind to come to the U.S. Okay, we will help because you are so talented. Okay, and all right. So I'm going to. Is there anybody any question or question asked? If it's not, you see that we have the Korean language after this. Okay, we are going to call Miss Adeline. Hello, Miss Adeline.
Hello, 老师.
Okay.
Hello.
Okay, so we are going to stop recording for the man. Okay, and then we welcome the everybody from the Korean. Okay. Thank you again.